Happy Friday. And it's not just any Friday. It's Friday, February 13, 2026.
Mm-hmm.
Now, you see that date, and you might think, don't walk under a ladder.
Right. Stay away from black cats.
But the research we're looking at today suggests that this moment, right now, might actually be the luckiest turning point we've seen in, well, decades for housing.
It's definitely a pivot point. We've spent, the last 10, maybe 15 years talking about the housing crisis like it's the weather.
Yeah, like it's a hurricane that just happens to us.
Exactly. And we just have to hunker down and survive it. But this source material we're diving into, Housing 2.0, it argues we're finally moving from complaining about the storm to actually, building a better shelter.
And this is not just policy fluff. I know we sometimes get these reports that are all 5-year plans and...
Aspirational goals.
Yes. This isn't that. This deep dive is based on a really dense technical publication from wikiresidence.ca and infodrone.ca. And it connects the dots between Montreal's architectural history, which is way wilder than I thought, and this sort of explosion in prop tech happening right now.
In places like LaSalle and Verdun, the premise is, it's pretty bold. It claims that innovation in housing is no longer some luxury item.
Right.
It's actually the only economic path left to affordability. For so long, smart homes meant, expensive gadgets for early adopters. This report just flips that entirely.
It's saying that to drive costs down, you have to automate how the walls themselves are made.
We have to fundamentally change how buildings think.
So let's unpack that, because the report starts by taking us back to 1967, where Montreal Expo 67 is on. And this architect, Moshe Safdie, he builds Habitat 67.
The house in the sky.
Exactly. If you're in Montreal, you know it. It looks like a pile of Lego blocks just tumbled onto a peninsula. It's iconic. But the report points out something that's often just, glossed over.
That, commercially, it was a total failure.
A logistical nightmare.
Absolutely. Safdie's vision was brilliant, prefabricated modules, gardens for everyone, density with privacy. He wanted to revolutionize city living. But the execution... The report says they had to build a dedicated factory right there, on site.
To cast, 354 concrete blocks?
And the weight was the killer.
It had to be.
Each block weighed 90 tons.
90 tons.
Just try to imagine the crane you'd need to lift a 90-ton living room. It was basically haute couture construction. Beautiful, one of a kind, but you could never scale it. It was just too heavy, too expensive.
So the dream of prefab modular housing just kind of died for 60 years. The physics didn't make financial sense.
Until now, the report calls 2026 the start of the revolution.
Right, and the big shift isn't stronger cranes. It's that we've changed the physics of the material itself. We are talking 3D printing, but not that gimmicky stuff we saw on YouTube a few years back.
Oh yeah, the soft serve ice cream machine making a messy wall. No, and that's a crucial distinction. The early hype was... let's say optimistic. You had these giant machines set up on muddy construction sites.
Trying to print concrete in Quebec in February.
Which is a complete disaster. Concrete chemistry, it hates freezing temperatures. The nozzles clog, the layers don't bond. It was a mess. The report says the industry finally grew up when it moved indoors. They call it off-site modular printing.
And this is that group in LaSalle, the RIDFRQNT.
Yeah, working with Cégep André Laurendeau. They just stop trying to fight the weather. They print wall sections in a factory, perfect temperature, perfect humidity. Then they just truck the finished walls to the site.
But here's the insight for me. It's not just about printing a wall. It's about this new material, this lavacrete.
Developed right here at ATS. It's a high-performance concrete designed specifically for our freeze-thaw cycles.
Because that's what destroys our roads, right? Water gets in, freezes, expands.
Exactly. Lavacrete is chemically engineered to resist that. But the material is only half the magic. The real cost saver, and this is the part that blew my mind, is the geometry.
Topological optimization. Sounds so academic.
It does, but the concept is basically biological. Think of a bird's bone.
Hollow, but incredibly strong.
Right. A bird bone isn't a solid stick. It has these little lattice structures, little bridges of bone, but only where the stress forces go. Where there's no stress, there's just air.
And our walls have always just been solid blocks of concrete.
Because that's the only shape a wooden form could make. But a 3D printer, it doesn't care about shapes. So the computer calculates exactly where the load is, and it prints concrete only there.
So you aren't paying for concrete that's just sitting there doing nothing.
The report cites a 25% reduction in raw materials. A quarter of your material costs just gone, just by using math.
And the speed. I saw metrics like 35 to 40% time gain on the structural envelope.
And that's where affordability comes back in. In construction, time is interest on a loan. If you shave 40% off the build time for the shell, you dramatically lower the financing cost. That's how you actually lower rent.
Not by using cheaper doorknobs.
No, by shortening the loan so the bank gets paid off faster.
And the Fibonacci project was the proof of concept here.
Yes, with Habitat for Humanity Quebec. That was the turning point. It proved to inspectors that these bird bone walls met the building code. It moved the tech from experimental to compliant.
Okay, so we have the shell, lightweight, perfect walls, but, and here's where I think you, the listener, might be skeptical, living in a concrete shell sounds cold, like a bunker. You need kitchens, wiring, you can't 3D print a toilet.
And that brings us to the hybrid model, construction 2.0 they call it. The printer only does the heavy lifting, the shell.
Okay.
And while that's happening, another part of the factory is building the interior module.
The plug-and-play kitchens and bathrooms.
Exactly. These things are complex. You need electricians, plumbers, tilers. In the old world, they'd be tripping over each other on site.
Oh, I've lived through that.
Yeah.
The electrician is late, so the drywaller can't start, and the whole thing cascades.
Precisely. In the hybrid model, the bathroom is built on an assembly line. Finished, inspected, tested, then a crane just drops it into the printed shell.
That sounds efficient, but also really complex. They have to fit together with, like, millimeter precision. If you're off by half an inch, nothing fits.
Which is the perfect segue to the digital twin.
BIM on steroids.
Building information modeling, yeah. But BIM used to be just a 3D blueprint for architects. The digital twin in 2026 is a full-on simulation.
So before they pour anything.
Before they print a single layer, they build the entire building virtually, and they simulate the assembly.
So if a pipe is going to hit a beam.
In the old days, you'd find that out on a Tuesday morning when the plumber hits it with a wrench.
And work stops for 3 days. And thousands of dollars are wasted.
With the digital twin, the software flags that collision in the simulation. It says error, pipe intersects beam. They move the pipe in the software. So when you get to the physical site, the surprise costs drop to almost zero.
It's measure 1,000 times, cut once. But a computer does the measuring.
And speaking of computers, we have to talk about the robots in these factories. Montreal is becoming a hub for physical AI.
The cobots, collaborative robots.
Right. This isn't like an old car factory where a robot arm does one weld for 10 years. These things are agile. The report says they can be reprogrammed almost instantly.
So Monday it's a studio, Tuesday it's a 3-bedroom.
Exactly. You push a code update, and the cobots switch tasks. It allows mass production to finally be flexible.
And there was a quick mention of mass timber, too, CLT.
Cross-laminated timber. Yeah, that's for taller structures, up to 18 stories. And the amazing thing there is the carbon footprint.
Right, because wood captures carbon.
So you're basically building a carbon bank.
Okay, I want to pivot. We built the house. Let's step inside. Because the report makes this really interesting distinction between a connected home and a cognitive building.
It's a subtle shift in language, but it's a huge shift in reality.
A connected home. That's what I have now. I have a smart speaker, a Wi-Fi thermostat. They're gadgets I stuck to the wall.
They're accessories. They aren't part of the biology of the house. A cognitive building that implies the intelligence is in the infrastructure itself.
The report uses the term optimized technical cavities.
Oops. I know, it sounds so medical. But think about it. Because the printer can do any shape, it can leave channels like arteries and veins inside the wall for sensors and cables. The wall itself becomes a nervous system.
And it all runs on the Matter protocol.
The universal standard, finally. It means the house operates as a single organism. The heating talks to the lighting, which talks to security. It's not about which brand you bought anymore.
The example that really hit home for me was the water leak.
The silent destroyer.
Right. A pipe bursts behind your drywall. You don't know for days. Then you see the mold, and it's a massive repair.
In a cognitive building, flow sensors detect a micro drop in pressure. The system knows water is escaping.
But it doesn't just beep at you.
No. This is where the digital twin comes back. The system pulls up that 3D map of your wall and shows the repair tech on their phone or maybe glasses exactly where the leak is.
X marks the spot.
Literally. You don't tear down a whole wall, you cut a 6-inch square, fix it, and patch it. It changes home maintenance from exploratory surgery to a precise outpatient procedure.
That's the invisible intelligence they talk about. It's not a robot butler. It's the house knowing its own health better than you do.
Which is safer and cheaper.
But. And there's always a but. The report has this great section called Reality versus Sci-Fi. Because when people hear 2026 future city, they imagine the Jetsons.
Or Blade Runner.
Right. So let's bust some myths.
Mm-hmm.
Myth number 1, the autonomous Martian colony in your living room.
Yeah, not happening. The reality is energy optimization.
Yeah.
The AI is watching Hydro-Quebec's dynamic rates. It decides, okay, electricity is cheap, I'll superheat the water tank now. It's boring, but it saves you real money.
Myth number 2, armed sentry robots at the door.
No. The security is way more boring and practical. It's a valve that shuts off the water main if that pipe bursts. It saves your basement, not your life.
Okay, but here's one that actually sounds like sci-fi. Self-healing concrete. The report lists this as a reality. How?
It's biology meeting engineering again. They embed these little microcapsules of bacteria in the concrete mix, and they just lie dormant.
Like seeds waiting for a crack.
Exactly. If a crack forms, water seeps in and it wakes up the bacteria. They start feeding on nutrients also in the mix, and as a byproduct, they produce limestone.
They excrete stone.
Essentially, yes. They fill the crack from the inside out. It seals the breach before rust can reach the rebar.
That is wild. It's like your driveway has an immune system.
And it extends the lifespan of the structure by decades, which, again, lowers the long-term cost.
And the last piece of tech is the user interface. It seems we're moving past apps on our phones.
By late 2026, the report suggests AI-powered glasses will be the main interface. You won't pull out your phone, you'll just look at the wall, and the temperature data will overlay in your vision.
It just removes the friction.
It makes the whole thing fluid. But zooming out, I think the most important takeaway isn't the glasses or the bacteria, it's the shift in mindset.
From haute couture to ready to wear.
That's it exactly. We've gone from Habitat 67, a beautiful, impossible dream, to a pragmatic industrial reality. Housing 2.0 isn't about making buildings look like spaceships. It's about using data and manufacturing to make quality living affordable again.
It's realizing we can't solve a 2026 problem with 1950s tools. We need the robots and the digital twins and the bird bone walls if we actually want to house everyone.
And do it sustainably. I mean, the mass timber towers, building 18 stories out of wood that captures carbon, that's a huge piece of the puzzle.
It does leave us with a really provocative thought, though. We've talked about the house having a nervous system, cognitive abilities, an immune system. It knows its own health status.
It starts to sound less like a machine, doesn't it?
Right. If my house knows when I'm home, how much water I use when it's sick, does it stop being a passive shelter? Does it start acting more like a biological roommate?
It's a valid question. If the walls are reacting and healing, the line between the built environment and the natural one gets very blurry. It's no longer a passive structure, it's an active participant in your life.
That's something to chew on as you look at your very passive, very dumb drywall tonight. Thanks for diving deep with us into the digital city.
Always a pleasure.
See you next time.